Hello once more. On this video, we will discuss mechanical advantage. And mechanical advantage is simply stated the amount of work that is advantageous by using an equipment, by using a machine, whether it is a simple machine or a complex machine. So there are two equations we look at. Mechanical advantage is the output force divided by the input force. The output force is the force that is being generated by the machine, by the equipment, by the simple complex machine you are using. The input force is the force that you're putting into it. Okay, and this of course gives you mechanical advantage. So once more, mechanical advantage is the output force divided by the input force. Can I have this in a different variation? Yes, I can. So if I bring the input force up and I multiply the input force by mechanical advantage, then I end up with input force. Therefore, mechanical advantage, in this case, multiplied by input force gives me the output force. Now, can I solve for input force? Yes, I can. I will simply bring down mechanical advantage. So now I have mechanical advantage, okay, it's at the bottom. And therefore, I have input force equals the output force divided by mechanical advantage. Okay, so this is one way of looking at mechanical advantage. Back to the original, and let's look at the other one. Still, mechanical advantage equals input distance divided by the output distance. For example, if you're pushing an object for a distance of 5 meters, but the resulting distance is only 2 meters, okay, that's what we look at. The examples of boats putting the boat on the ramp. You crank and you crank on that tourniquet, and the wires is just turning and turning, and the boat is slightly moving, which means that the advantage is that you are inputting, okay, a certain distance of rope or wire, and the output distance of the boat is very little. But why is that an advantage? Is because the force that you're generating is much less. Okay, so let's play with this equation over here. And if I bring the output distance up, okay, let's make some space over here. Output distance divided by, sorry, times mechanical advantage gives me input distance. Can I solve now for output distance? Yes, I can. Simply bring this down. Now I have output distance equals input distance divided by mechanical advantage. Okay, so what are the units of these two equations? Okay, so distance, of course, is any distance, whether it is meters or whether it is kilometers and whatnot. Mechanical advantage is just a simple number with no units. In the case of course, force is measured in newtons. Okay, so newtons over newtons cancels out. I end up with a single number. The same case over here. Distance over distance cancels out, and I end up just with a single number. Let's do some sample problems. The question says, what is the mechanical advantage of a ramp with a distance of 10 meters and a height of 2? So let's see how it looks. Let's do a little illustration over here. I have a ramp of 10 meters. Let's call that 10 meters. And a height of only 2 meters, let's say. So 2 meters going down. So what I really have is 10 meters going up. Okay, so this is 10 meters, okay, going up, and the total height from top to bottom is only 2 meters. So I need to find the mechanical advantage of this equipment, okay, of this ramp, mechanical advantage. And I know that mechanical advantage, let's abbreviate that with MA. So mechanical advantage, okay, equals. So what do we know about it? I know that I'm dealing with distance, so the distance will be input distance, okay, divided by output distance. Input distance is 10. So here I have it. Input distance over output distance. Let's plug in some numbers. And I have my input distance is whatever I pushed the object up. Okay, so it is 10 meters. 10 meters is my input distance. I will divide that by whatever the outcome was. Because if I put the object from here, okay, starting right over here, let's say, object started right over here, and I pushed it all the way up, and the object ended right over here. Yes, I pushed it 10 meters, but in reality, my outcome was only 2. Okay, so it is the 10 that I have now divided by 2 meters. 2 meters. Okay, 10 over 2, and of course, my units cancel, and meters cancels meters, and I have no units left. Therefore, my mechanical advantage is 10 over 2, which is just 5. In the case of this ramp, the mechanical advantage of using a 10-meter ramp to get an outcome of only 2 meters is 5. Just 5. No units because the meters cancels the meters. Sample number 2. You use a simple machine to push an object and the force you are using is 5 newtons. So you're pushing this object with a force of 5 newtons. If the mechanical advantage is 3, how much force is generated by the simple machine? Okay, so let's write down the equation. And I have mechanical advantage. Okay, in this case, I am using the force equation, and it is going to be output force. Okay, that's how much force is being done by the machine divided by input force. That's how much force you are using. Okay, so we're going to divide that over that to give me an answer. But what do I have? I do have mechanical advantage, which is 3. And I do have the force that you are using, which is 5. So you're pushing with a force of 5 newtons, and the advantage by the machine is 3. So I need to rearrange this equation, and I will make the equation useful so that I'm looking for the output force. Okay, so I have that over here. Now I have input force, which is what you're using, and that'll be times mechanical advantage equals the output force. I am looking for how much force the machine is doing for me. So plug in those values, and I have my input force, which is 5 newtons, times mechanical advantage of 3. Okay, multiply those two things, and I end up with 15. In this case, I end up with 15 newtons. Let's try it again. The input force is how much force you're inputting into the system. In this case, it's a force of 5 newtons. The advantage by the machine is 3. 3 times the amount you're using. of course. So the output force by the simple machine is 15 newtons. Notice that I have a unit of newtons multiplied by no unit, which means that the only unit left will be newtons. In this sample, I have 15 newtons is my output force. So we've done two samples, okay, based on these two equations. And can I put these two equations next to each other? Yes, I can. I could simply do this, okay? And they mean the same thing. So the output force is relevant to the input distance, and the input force is relevant to the output distance. Not to confuse you, but these two equations simply give you a mechanical advantage of a machine over whatever force you are utilizing. I hope this helps you out.